Okay. I want to remind everyone the test is tomorrow. Make sure you look at the practice test. That's a good way to make sure you know what's being covered tomorrow. Not today. Today's material is not on tomorrow's test. Okay. All right. So today we're going to be talking about naming binary compounds. And there are two kinds, really three if you count acids. Now, on today's dry lab, I don't want you to do the acids because we're going to cover those when we study acids in Unit 5. Okay, so today you're only doing ionic and covalent compounds. I'm going to talk about how do you figure out what you got. The problem is the naming conventions are different for each one. So you have to know what you're working with. Okay, so what does binary mean? Two. That's right, two parts. Okay, now the handout I gave you is this one here. It says it's a common ion chart. That means there are other ions out there besides this one. These are just the most common ones. Now, there's two ways to figure out what an ionic compound is. One group says it's a metal and a nonmetal. So remembering from periodic table, the nonmetals are to the right of the metalloids up here. These are metalloids along the squiggly line, and then all the rest are metals. Okay, so that's one way people say this is an ionic compound. You have a cation, excuse me, a metal and a nonmetal. The other way is a cation plus an anion. Metals usually form cations. Nonmetals form anions. So it's saying the same thing, but it just depends on who's lecturing to you, whether you get which version. Now, what I've done is I put together a common list. Now, if you take 1A or 3A, you're going to have to memorize a subset of this. They want you to know, like, phosphate is PO4 minus 3. And you don't have to memorize them in this class. I'm going to give you this on the next test, okay? I want you to be able to use this. Use it. Because you have a smartphone, and within 3 seconds, you can find out all that stuff. Why memorize it when you can just use your phone? So that's my opinion. Okay, so we have covalent, ionic, and acids, as far as naming goes. Now we're covering acids, like I was saying before, in Unit 5. So today we're going to talk about covalent and ionic naming. On your dry lab today, their acids are included, so just don't do those. You can do them if you want, but you don't have to. I'm going to be focusing on covalent ionic when I look at your worksheet. Okay, so the bottom line is, how do you tell the difference? Okay, the first thing you do is you see if it's ionic. Does it have a cation over here and an anion, or a metal and a nonmetal? If it is, then it's ionic. If it's not ionic, then it's covalent. So you just check for whether it's ionic first, and then it defaults to covalent if it's not. Sometimes they call covalent molecular. I'm not sure which is more popular. but depending on what textbook you're using, what instructor you have, you'll hear either one. In fact, I think your dry lab talks about molecular. Okay, so say we have something like this. Right. Okay, common table salt, sodium chloride. Is that an ionic compound or a molecular compound? Ionic. Sodium is a metal, chloride is a nonmetal. Sodium is a cation, chloride is an anion, so it's ionic. So what you're going to do is you look on your handy dandy common ion chart. Here's sodium, +1, chloride, -1. Now remember, on your periodic table, everyone in the group has got the same charge. Okay, everyone in the group has the same charge. So if you have something like let's see, let me make sure here. Okay, beryllium chloride. The first thing we do is check to see if it's ionic. Beryllium is not on the common ion chart. So remember what I told you? If it's not ionic, it's covalent or molecular. However, it's in group 2 up there. And if we look at other, like magnesium is on the chart, it's right here. And those are +2. So that means everything in that group is a +2. So that includes beryllium, even though it's not on the common ion chart. So check your periodic table as well. Okay. So beryllium then, and chloride we already determined is an anion. So beryllium chloride is ionic. Sodium chloride, ionic. Now, why did I put the 2 there on the chloride? This, yes. Perfect answer. Okay. When we're doing ionic compounds, the charge has to be neutral between the cation and the anion. This is a +2. This is a -1. They don't balance. We have 2 -1s here, a +2 here, and it balances. So this is illegal because the charges don't balance. Okay. Yeah. And has an ionic bond as well. Yes. I'm sorry, say again.
Is the word or the words?
Yeah, what keeps these 2 or 3 together is an ionic bond. So it's an ionic compound. So the bond determines whether you call it a covalent or ionic. Is that okay? All right. So ionic has to balance. Now the problem is okay. aluminum sulfate. What's the formula for aluminum sulfate? Well, do we have a cation for aluminum? Look on the left of your chart. Is aluminum there? What's the charge? +3. What's the charge in chlorine again? Okay. And what's the charge? Excuse me. What's the charge in sulfate? -2. And sulfate is right there. Okay, so how do we write the formula then for aluminum sulfate? Well, aluminum is +3. The group SO4 got a charge of -2. Does that balance? No. So what do we do? Okay. If we have 2 of these and 3 of those, 2 + 3s is +6. 3 -2s is -6. Now it balances. So the formula is Al2 SO4 3. Notice I put parentheses around the SO4 because if I didn't do that, it would be excuse me, be O43, which doesn't make any sense. Okay. So anytime you have a grouping, put parentheses around it, unless it's 1. You can still put a parentheses around it if it's 1, but most of the time people don't put parentheses around if it's just 1. But you're more than correct if you do. It's not a problem at all. Okay, so think of the common denominator. If I was to add 1/2 + 1/3, what's the common denominator? 6. So whenever you get a situation like this, think of what would be the common denominator. 6 in this case. And then how many 3s are in 6? 2. How many -2s are in 6? 3. So on your dry lab, you're going to be going from naming to formula, formula to name, back and forth. Yes, I think I understand. I mean, like if you're, like how many oxygens do you have? Is that what you mean? Yes, because this parentheses affects both those. So we didn't put a 1 down here, but there's a 1 there. So we have 3 S's and 12 O's. Because the parentheses means we have 3 of those. Okay, now let's look at let's see. Okay, we have phosphorus, 3 phosphorus, 4 oxygens. Is that ionic or covalent? Well, is P a cation? It's an anion. So we have an anion, that means it's covalent or molecular. So how do we name this guy? We're going to be using these prefixes right here. Mono, di, tri, etc. Now, the reason why we have to name those is because there's no charge involved. Because with ionic, the charges determine how many of each you have to balance. But because we don't have any charges involved, we have to actually tell it how many we have. So it's in 2 parts. The first one comes right out of the periodic table. And the second one comes out of the top right of the ion chart. Oxide. Now we have to say how many. So this is going to be triphosphorus tetraoxide. Now, normally what we do when we have two vowels together like that, we kind of leave off the second one. So we write it as tetra XIDE, triphosphorus tetraoxide. So for covalent, now a big mistake a lot of students do is when they're naming ionic stuff, they'll throw in the tetras and the tris and the dis. No, ionic stuff doesn't require that because we're balancing charges. We don't have to throw in how many. But with covalent or molecular, we have to, because there's no way to tell how these are going to balance out. So we have to put in these prefixes to determine the number. Okay, so let's do some more here. Oh, let's see. Oh, one other thing. Notice on acetate, there are two. They're equivalent. The top one is how organic chemists refer to acetate, and the bottom one is how inorganic chemists refer to acetate. Same with formate on the right, over here. Top one's organic, bottom one is inorganic. They're both correct. It doesn't matter which one you use. Okay, so okay, let's name this. So first of all, is it ionic or covalent? Ionic. Vanadium is a cation, sulfate is an anion, so it's ionic. There's a problem though. What's the problem with this? Look at the bottom left on your chart, on your ion chart. There's not one vanadium, there are 3 vanadiums. So the Roman numeral refers to the charge. Now you're going to find the metal cations, the metals that are in the middle there of the periodic table, frequently have multiple versions of the ions. So that's what this does. This distinguishes what the charge is. So vanadium 4 is vanadium plus 4. It's all over the place. Titanium, 2 versions of titanium, tin, lead, a lot of metals down in here have multiple versions. Some are more stable than others, hence they're more prolific. Okay, so back to our original problem here. Okay, so how do we name this then? Well, for sure it's the vanadium, right? Well, which one is it? Well, we don't know yet. There's only one version of sulfate. What's the charge on sulfate? -2. And we have two of them, so what is that? -4. And we have one vanadium to balance out the -4. So which vanadium are we going to use? The vanadium 4, because it's a +4, exactly. Now, sometimes there's only one, like silver is almost always a +1. Rarely do you find it anything else. This is silver right here. And it's not 108, it's 107.87. That means there's some other isotopes around, but usually it's only +1. If there's only one of them, you don't have to put parentheses down. If you want to put parentheses and put a Roman numeral 1 in there, that's fine, so it's consistent, but you don't have to. Okay. Now, if you looked at a food label and there was that in your food, it's not going to say iron 3. It's going to say ferric. Okay, the other, I call them other names, the top here. Those are the old names. The newer names that only been out for like 80 years are these over here. So agriculture and the food industry uses the old names. So if this was in your food, you'd see ferric chloride on the label, not iron 3 chloride. It's just the way it is. Agriculture is the same way. Trying to think. Yeah, supplements are like food. So they fall in it, so to be ferric chloride. Okay, rust. Formula for rust. Ferric oxide, not iron 3 oxide, ferric oxide. Okay, so at this school, they don't teach these. I don't know why. They don't. The department has said, we don't want them to learn these, only these. However, your life, you're going to be seeing these all the time and rarely these. So I like to teach you both. Okay. I think that's all you need to do in your dry lab today. I'm trying to think of anything else you can run into. So the process is it ionic or covalent? If it's ionic, you use the ionic standard for writing. If it's covalent or molecular, you use the molecular one. Your first step is an I or a C. I for ionic, C for covalent, or IM. Okay. Then use the appropriate way to write these. You'll be practicing going from name to formula, formula to name. And that's all unit 3 stuff. So they'll be on the third test. Now, your test tomorrow, I highly encourage you to look at the practice tests. Your test is going to be cover the same material, and it'll be about the same length as well. Yeah. In class. Okay, so any questions about either the test or naming these guys? Yeah, we'll have a lab afterwards. Yeah, yeah. Yep. Covalent is not ionic. That's why I just tell people. That's why I check for ionic first. If it's not ionic, it just defaults to covalent. Okay, so those of you who have lab Friday, that's what we're going to do starting now. For those of you who have a lab Saturday, if you'd like to stick around and do your lab tomorrow, today, you're more than welcome. We have plenty of room. Okay, if you don't have your lab packet, let me see if